friends, good evening all. Welcome to GATE 2026 Score Booster Series behalf of ACE Engineering Academy and myself Sriram, working in ACE Engineering Academy for Digital Electronics. And I have selected some questions, some typical questions and model questions, and some of them are from the previous year GATE. Let us solve this problem, guys. Yeah, good evening, guys. Good evening. And try to respond, okay? If you try to give the answers, then I can understand whether students are following or not. The number of essential prime implicants, EPIs, number of essential prime implicants of the Boolean function f of ABC, ABCD, 4-variable expression, obtained by the multiplexer circuit shown below. So, this is a GATE model 2 marks question. There are 3 steps here. First, step number 1, we need to obtain the expression for the output. And step number 2, we need to load the minterms. We have to identify the minterms and load them into the K-map. Then we can go for the grouping, and you know how to find the essential prime implicants. Okay. So, for that there are different ways. Generally, if you see, you can find the method like A bar B bar f of ABCD is equals to A bar B bar into I naught, some expression. We can expand it to the canonical form to get minterms. But that is one of the method. You better to use design table, right, in the reverse order. That means we are trying to find the minterms from the design table itself. But what is a I naught here? See, I naught is exclusion OR operation, right? C X NOR D. What is the complement of C X NOR D? 2 variable XOR gate complement is what? C XOR D. And complement is C X NOR D, again complement C XOR D. So, X NOR complement XOR complement X NOR complement XOR. Then you know the table I naught, I1, I2 and I3. A and B are the select lines. A bar B bar, A bar B, AB bar, AB. You know, C bar D bar, C bar D, CD bar and CD. Right. What is a I naught? I naught is actually a expression which is actually carrying C X NOR D. First, you better to write the minterms 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 and 15. It should be X and OR operation, right? I naught. What is the input pin or input for I1? XOR operation. X NOR operation, XOR operation. Of course, in terms of only C and D. So, how can you get it? See, to get X NOR operation between C and D, what are the terms should be involved? Very simple. X NOR operation, it should be a 0, pin number 0 and minterm 0 and minterm 3. Now, you verify. C bar D bar plus CD is nothing but C X NOR D. So, in order to get X NOR operation here, these 2 minterms have been selected. That is the meaning. Okay. Next, XOR operation. C bar D plus CD bar. C bar D and CD bar 5 and 6. X NOR operation 8 and 11. XOR operation 13 and 14. And this is the time to take. You can even directly take this minterms into the K-map also. So, that is a method 4 we have done in our class. But here as everyone should understand the method or solution, that is why I am using little lengthy procedure. First we have obtained the minterms, now we are loading them into the K-map. But in fact, we can directly take these minterms into the K-map, that is also one method available. Okay. Right. So, A bar B bar, A bar B, AB AB bar, C bar D bar, C bar D, CD, CD bar, no need to write because we need to find only EPIs. Okay. What are the numbers here? Minterm numbers 0, 1, 3, 2. Of course, we can directly take the minterms these 2 and these 2, right? 4, 5, 7, 6, 12, 13, 15, 14, 8, 9, 11, 10. 0 and 3. 0 and 3, okay, then 8, you take 8, minterm 8, 5 and 13, 5 and 13, 6 and 14, 6 and 14, 3 and 11, okay, these are the minterms. Let me go for the grouping of them. This is a pair. As we have a pair, we cannot go for the single cell grouping. Diagonal is not allowed, hence we should take a pair. This is one pair. This is also one pair. How many groups? You don't need to identify the group information. So in every group, every pair, we have multiple minterms. They have been participated in grouping only once. So that at least if you find one minterm, in short, I am telling you, at least if you find one minterm which is participating in the grouping only once, not multiple times, then that entire group can be considered as essential prime implicant. So how many essential prime implicants? This is one group, one essential prime implicant. This is one group, one essential prime implicant, and one essential prime implicant, and this one too. So totally there are 4 essential prime implicants. And I have received only one correct answer, right? 212, yes, Mr. 212, very good. Yeah, and CR7, of course, correct. Yes, thank you guys. Now we'll go for the next problem. So we did nothing, very just directly we have taken the results of I1, I2, I0, I1, I2, I3. Accordingly, we have calculated the minterms and we have loaded the minterms into the K-map. As usual, we know how to find the EPI, prime implicant, redundant prime implicant, the processor. But this is a question given for what? Essential prime implicants. I am changing the slide. So, this is a 1 mark bit model. Just for a 9-bit digital to analog converter, the full scale output voltage is 12 volts. Full scale voltage is given and the step size is asking. So, full scale means all one's value, okay, all one's value, 2 power n minus 1. So, you know, full scale equal to delta into 2 power n minus 1. So, what is a delta or step size is equals to full scale voltage is how much? 12 divided by 2 power n minus 1, but I am writing 2 power 9. Why? Because you see 5, 10, 23, 60. So, there is a lot of gap, of course. We can find some considerable gap between the options. So, we can ignore this minus 1, no need to worry about it, okay. And if you solve it, you will get the answer around, if I am not wrong, you will get around 23.45 or something millivolts. C 212, yeah, correct, yeah. Actually, I can't see your names, or I think your names are given like this only, right? 212, CR7, like that I am having your names here in the live. It's okay. 23.375, yeah, CR7, get. So, which is very near to the option C. Option C. Please, everyone should involve, okay? Just keep on try and type your answers. Very interesting question, but remember, this is important for ECE. MOS logic, FSM, finite state machines. These two topics are very important for ECE and instrumentation, not for electrical, okay? Please. Right, sir. The circuit shown below can be operated as Y0 is output. This is an inverter, okay? Simply not gate. Instead of positive and ground or minus VEG or minus VDD, he has given just variables, okay? A is a variable, B is also one variable, that's all. So, given circuit can act as encoder, decoder, multiplexer and buffer. I can immediately remove, Y0 is only output now. So, which of the following option is having actually a single output line? Encoder cannot have single output line. Encoder is having 2 power n input lines and n output lines. Decoder 4 is to like 2, right? 2 power n input lines and 2 output lines, or I'm sorry, n output lines if it is a decoder. But multiplexer and buffer can have only one output line. I can eliminate option A and option B. Of course, with the same elimination method, I can obtain the final answer, but I want to explain some information about this kind of circuits. Very simple, guys. Assume C value is initially at 0. If C value is 0, what is the 0 complement? 1. If the gate is 1, I am not talking in terms of gate to source voltage VGS, which should be greater than like VGS minus VT should be greater than VDS. No need of all these things here to identify the logic in digital electronics. Just you need to understand whether that MOSFET is in turn on or turn off. You know already. So, for a P MOSFET, this is a PMOS and this is a N type or NMOS, enhancement type MOSFETs. So, for a P MOSFET input gate voltage should be low. Strong 1, strong 0. This is a terminology we have been discussed, right? So, high voltage, logic 1, low voltage, logic 0. Logic 1 can bring the N-type MOSFET or N-channel MOSFET into conduction state. Logic 0, I mean low voltage, can bring the P-channel MOSFET into the conduction state. And conditions apply. Hello my dear friends. There should be a potential difference between the source and drain. So, there should be a comfortable path to flow the current from high potential to low potential. Meanwhile, we are providing the sufficient gate voltage. Then only we can expect the current. In that case, only we can say that MOSFET is in on state. Got it? Yeah. So, we do not know the values of A and B. You don't need to worry, of course. So, if this is 1, I can say that P MOSFET is turn off, M1 is off, and there is a possibility to turn on the M2. So, probably M2 can be turned on. Sir, for example, look at this man, this is 0. If it is high voltage, BI is high voltage, then current can flow from high voltage to low voltage like this, output will be logic 1, or otherwise output is 0. That means if B 0, output 0, B 1, output 1. So, what is output B? That is it. So, if C is equals to 0, we can simply say Y naught is equals to B. If the C value is 1, if the C value is 1, okay, 1 bar, this is going to be 0. Undoubtedly, M2 transistor can be off, this MOS transistor can be off, but possibility is there for M1, hence what is output? Y naught, it is decided by A value, A can be either 1 or 0. So, that is why if C is equals to 1, Y naught is equals to A, that is all. So, I can relate it to multiplexer. It is not a buffer, definitely. Buffer means output should be same as input. Output should be same as input. So, this is I naught and I1. If I take the select line, something like S naught, this is the output Y naught. So, C can be act as a select line. It is actually providing the path. And C0, what is the Y naught? B. That is why 0, I mean C bar I naught. So, that this is B and this is A. So, given is acting as a 2:1 multiplexer. Given circuit is acting as a 2:1 multiplexer, or simply given is a multiplexer. Yes, good. Multiplexer, right. I am changing the slide, guys. Consider the state diagram of a sequence detector. These two questions are intentionally selected for ECE, guys, okay, right, because I have to cover both ECE, instrumentation and electrical syllabus here, at least some of the questions. Yeah, this is one of the important model from the FSM, finite state machines. Consider the state diagram of a sequence detector. It is actually having 3 states, guys. If the input sequence of a given FSM is, see, input sequence is given. What is the input sequence? X is equals to 001100, 001100, 110011, 110011, 110011. Okay. So, what is the question? What will be the output sequence Y? Just he is asking the output sequence Y. So, we need to understand the sequence which is going to be detected by this state diagram. One is a failure state. If one arrived, output is 0, stay there in the same state. So, we can ignore ones. Once if zeros are coming, this machine is going to start collecting the zeros. First 0 and then 1 is a failure case, go back to initial state. And if another consecutive 0 is arrived, what is output here? 1. Can I say 2 zeros? Yes, of course. Again 0, again output is 1. Or if failure case means after 2 or more than zeros, if there is an arrival of 1, machine is going back to initial state by giving you null, 0. So that is a failure case. That means this is a machine is going to collect or detect consecutive zeros. Minimum, of course, 2 zeros, or we can say 2 consecutive zeros. But here, what is the indication of this loop? It indicates what? Overlapping sequence. Overlapping sequence, right? But in fact, in this question, even if student miss the overlapping, of course, you have to analyze it in exam carefully. There are so many questions found in this method, right? So this is just for model to recall the story only. I am giving you this question or this model. So luckily we have only 2 zeros and 2 zeros. If there are 3 zeros, then also what will be the case? We have to identify it. So what is output? 0 and 2 zeros, 2 consecutive zeros will complete the task. So that output is 1, because it is going to detect 2 consecutive zeros and it will produce a 1. Then failure case, 0, 0, 0. First time 0, there is no importance. Minimum you have to collect 2 zeros. Second 0, right? Output is 1. 0, 0, 0. Output is 1, 0, 0. For example, if you have another 0, you would have another 1 here, okay? Because it is what kind of a detector? Overlapping sequence detector. So 0, 1, 0, 0. 0, 1, 0, 0. Next 1, 0, 0, 1, 0, 0. Which option? Option B. B is the correct option. B is the correct option. Please verify. Yes, yes, yes. Mansoor, Ali, Srinivas, 212, yeah. Right, thank you. Good, good. Please keep on trying. I am going for the next slide. I am changing the slide. Very interesting question. The simple block diagram of a 8-bit successive approximation type ADC. So, what is the n value? 8. Operating with a frequency 5 megahertz. I am not writing the data. If you write the given data, definitely you can trigger with the correct path, okay? And then clock is shown in figure, of course. Neglect the timing overhead. Internally there might be some delay, okay? He is asking to neglect it. Of the internal circuit, the frequency or frequencies. That means what, man? Hello, this is what? MSQ question, huh? This is belongs to the MSQ question. But here you will not find ABC, okay? You will find some check boxes and radial buttons can be differentiated whether it is a MCQ or MSQ, okay? Then what is the question? See, the frequencies of the analog signal that can be converted using this ADC is approximately. I think you know analog signal range. This is the analog signal that can be handled by the given ADC relation 1 divided by 2 times that of conversion time, 2 times that of conversion time. And we have derived it with the help of sampling theorem, right? You know, in the sampling and holding circuit, link up with sampling and holding circuit and ADC converter. By using the sampling theorem concept, we can derive this relation. F less than or equals to 1 by 2 into conversion time. For successive approximation type, what is the conversion time, guys? Conversion time is equals to simply n into TCLK, n into clock duration. But what is a clock duration here? Clock duration is equals to 1 divided by clock frequency. What is the clock frequency? 5 megahertz, 5 into 10 to the power of 6. And you please verify 5 into 10 to the power of 6, you can find around I think 200 nanoseconds. 200 nanoseconds. Then F analog should be less than or at least equals to. It should not be greater, okay? Worst case equals to that value 1 divided by 2 into conversion time. What is the conversion time? N. What is the N value? 8 bit, okay? 8 into 200 nanoseconds. You write into 10 to the power of minus 9 and you can find this value. Please calculate it. Please calculate and type the answer. Please calculate it. Someone is saying B, C and D. I don't know. Type the value guys first. Who is this? 212. Good year. Very good. Very good. MS. Keep it in mind. It is a MSQ question. Okay. It is not MCQ. MSQ guys. Still I am waiting. If you calculate it, you will get around 312.5 kilohertz, right? 312.5 kilohertz. So, beyond this frequency, the system will not work, no doubt, right? So, 198 kilohertz, B is correct option. 312 less than 312, okay. Next 1 megahertz, we cannot operate it. Someone is selected D, option D, okay, option D. The students who are selected option D, listen China, 212, my dear students, 312.5 kilohertz is correct answer. You got the correct answer, but you are going to get negative mark. Please apply common sense guys. So, in the hurry also, your brain should be very stable, no. 312, everyone will look at the numbers only, but why? What about the frequency range or otherwise units, kilohertz? This is, you have obtained kilohertz, na? How can you select 312? This is the trap. Immediately, students, see, so many students selected option D. This is wrong, na? 312.5 kilohertz is the highest. He has given 312, but megahertz. How can you select D? He cannot select D. I think you got the point, okay? So, B is kilohertz, correct? 1 mega wrong. 300 kilohertz. C is also correct. C is also correct. Please verify. Am I clear? Very good. 212. B and C. That's it. Hope I am clear. Okay. C also near. That's what. Money. Correct. 300 and B. 198. Both are correct. MSQ question. Okay. Multiple select question. I am going for the next question, guys. I am going for the next question. What about 312? 312, who is this? CR7. Dear CR7, I can't see your name. Please observe it. 312, that's what I told you, na. It is not kilo, it is mega. Hello, dear. His name is CR7. Is it clear or not? How can you select option D, China? It is mega, na? But our answer is in kilohertz, na? Right? Okay, okay. If not in option, okay, obviously. Correct. Okay. I am going for next slide. The status of the LED, light emitting diode, it is just like a diode, na? Anode should be more potential than cathode. In the circuit given below, LED will blinks continuously on off, emits the light, always off, none of the above. 1 mark bit here, you can select it. Watch and select type question. Anyone in the live, try to give me the answer. Seriously, please don't go for the expression simplification, okay? What is this? This is A bar, okay, A bar. What is the second line? B. For the second gate, gate number 2, what is this? A. Second input is what, you know, B bar, right? I think you know, one leg is having a negation complement. A bar XOR B, or otherwise A XOR B bar. A bar XOR B or A XOR B bar will give you opposite operator, two variable case. This is equals to, this is same as A XOR B bar is equals to what? A XOR B. Value can be anything, I don't care, okay? It is same. If this is A XOR B, this is also A XOR B. So I am assuming it is something like K, logic 1 or 0, this is also the same. Exclusive OR gate inputs are same. Exclusive OR gate inputs are same. If inputs are same, what is output? If inputs are same, exclusive OR gate output is 0. If this is 0, okay, for all time t, how this LED can emit the light? So it cannot be turned on. According to this requirement, cathode should be low voltage, anode should be some high voltage, logic 1. So that's why in this circuit, LED will never emits, LED always off, okay. See, LED is always off. LED is always off. Yes, yes, C, R7, right? Correct. Going for the next question. I am changing the slide. And this kind of questions are important for all branches, okay? Important for all branches. Consider the circuit as shown below. The diodes are ideal. Base to emitter voltage on, I mean, if you give this much of voltage, at least 0.8, the diode can be turned on. It's okay. So logic values is asking. Inputs are 0 for logic 0, 5 volts for logic 1. As usual, high volt for logic 1, low voltage for logic 0. But you no need to solve it very seriously. You no need to solve it for very seriously. This is an inverter now. This is simply one NOT gate. So what is this? A bar. And this is also one inverter. So what is this? B bar. Both are inverters. And you know already, if two diodes are meeting at this point like this, if you connect the diodes like this, in the positive logic, that means general logic, high voltage 1, low voltage 0. In that case, if any input of these diodes are high, output will be high. Drop may be excluded, of course 0.7 drop will be there, you no need to worry. So if any of the input is, for example, if it is X and Y, what is output? If any of the input is high, output is also high. At least one input is high, output is high, OR gate, you know well. So what is the output? X plus Y. So that means this is a OR gate now. What are the inputs of OR gate? A bar and B bar. So output is A bar plus B bar. Apply De Morgan's AB whole bar. AB whole bar. B is the correct option. Please verify. I think it's maybe around 8 to 10 seconds gap between live and your video. So you should try to react immediately. Then only I can see your answer. I am changing the slide. I am changing the slide. Very interesting. Consider the given Boolean function f is equals to a XOR b. But here students will look at a XOR b operation only, but you have to understand that given is a 4 variable function, okay? Given is a 4 variable function. MSQ question. Which of the following is R suitable standard Boolean function in canonical form? Okay. MSQ. So how to solve this kind of questions? We have to take a 4 variable K map. First of all, what is a I am not going to solve it by writing f of ABC, A, B, C, D is equals to A XOR B, na? So A bar B plus A B bar. But seriously, you please don't start solving this question like A bar B into C plus C bar into D plus D bar plus A bar A B bar into C plus C bar into D plus D bar, it will definitely takes at least one minute extra time. You directly take the K map. And keep it in mind, you have to take the K map based on or according to the variables. Given is a 4 variable function, okay? Given is what? 4 variable function. So, AB and CD, A bar, B bar, A bar, B, AB, AB bar, C bar, D bar, C bar, D, CD, CD bar, 0, 1, 3, 2, 4, 5, 7, 6 minterms, okay? 12, 13, 15, 14, 8, 9, 11 and 10. So, what are the minterms? That we have to understand from the function. What is the result after taking the group of the minterms? The result is equals to XOR operation, A bar B plus AB bar. So, what might be the minterms? They have been involved in the K map grouping. Just think reverse, okay? In order to get A bar B, you see guys, all these 4 minterms have to be grouped. So, then only what will be the result? A bar B. In order to get AB bar, see this is AB bar result, na? Here we should not have any common terms. Then only result can be AB bar, that's it. This group will give you A bar B, this group will give you AB bar. So, final conclusion we have obtained SOP function. Sigma M of 4, 5, 6, 7, 8, 9, 10, 11. So, sigma M of 4, 5, 6, 7, 8, 9, 10, 11, A is correct option. Let me change this, A is correct option. Sigma M of 2, 3, C is wrong answer, but another 2 options are given in POS form. You have to check it now, but it is very easy to convert it, okay? What are the missing numbers here? Pi M of 0, 1, 2, 3, 12, 13, 14, 15 is a POS function. 0, 1, 2, 3, pi m of 0, 1, 2, 3, 12, 13, 14, 15, 12, 13, 14, 15, okay. So, B is also correct option. B is also correct option. Any answers? Very good here. C, R7, A and B. Srinivas 1686, very good. A and B. 212, very good. Guddu 212, right. Answer is A, B. I think you have given previous question answer, okay. Right, China. Right. So, it is a MSQ question. Both A and B are the correct options. This is a simple way. Okay, seriously, please don't write the missing minterms or missing variables, expansion, converting into canonical. 100% that is also correct method. It will take definitely at least 50 seconds to 1 minute extra time. You can save 10 seconds, 10 seconds, 10 seconds for every question. You can utilize the time for some complicated questions, no? Okay, I am going for the next slide. Yeah, very interesting. It is a NAT, numerical answer type question. Of course, I have collected this from previous year gate, I think, NAT question. Numerical answer type. The propagation delay of the XOR gate, AND gate and multiplexers are given. XOR gate 4 nanoseconds, AND gate then 2 nanoseconds. Multiplexers 1 nanoseconds respectively. Last one is multiplexer na 1 nanosecond respectively. If all the inputs P, Q, R, S, T are applied simultaneously and maintained, held constant, okay. The maximum, very important observation, he is asking maximum propagation delay. So, once if the student say these kind of questions, immediately they will jump and find the highest values from the input to output. Please don't do it, okay. 4, highest number 4, next 1, next 2 here, next 1, 4, 5, 6, 7, 8 like that students are doing, that is wrong. Because the maximum propagation delay of the circuit is decided by its critical path, and that too how the route is established from the input to output. How can we make a certain route from the input to output of certain combinational circuit? If it is having any control lines, that control line will take care of it. And here multiplexers are the controllers. Multiplexers will decide the route, right? It will decide the path. And how the multiplexer will decide the path? Based on the select line value. That is very, very important and interesting question. So, he has given P, Q, R, S, T as inputs, but you have to separate. T is a select line. T is what? Select line. So, T value will decide the route. If T 0 in multiplexer or select line 0, I naught will be selected, you know well. If select line is 1 in multiplexer, I 1 will be selected, because given is a 2:1 multiplexer, simple. Okay, now I am assuming that initially T value is 0, okay, I am assuming, this is my assumption, okay, T 0. If T 0, S not 0, that means which one is a path? This is a path, will be selected, it's okay, but seriously you do not start counting these values, okay. Hello my dear friends, if S naught of first multiplexer is 0, S naught of second multiplexer is also 0, man. So, this is a line going to connect to the output. That means second multiplexer is going to take I naught or I1, I naught. Then why are you struggling for I1? No need, because multiplexer is going to take the sample from I naught only here, but I naught is actually provided by this AND gate. Please try to understand the path here, very interesting, okay. This is a path, na? This is a path. That's why if T value is 0, T value is 0. So, what is a path or delay from input to output? 2 nanoseconds, and then multiplexer delay is 1 nanoseconds. 2 nano plus 1 nano, 3 nanoseconds. And immediately please do not write 3 is the answer, okay. We have to verify all possible paths. There are only 2 chances, because first and second multiplexer S naught values are merged together. If you connect it to logic 1, China, if you connect it to logic 1, then what will happen? Let me change the color. If it is 1, this pin is going to connect to the output. If this is also 1, same line, okay, this is a pin connecting to the output. Then we should see, consider AND gate delay, this multiplexer delay, this AND gate delay, and then multiplexer delay, okay. AND gate delay, not the XOR gate delay, because what is a T value? 1. So, S naught will be selecting the 1 I naught value, okay, not the I0 value. That is why 2 plus T value is 1. Then delay 2 nanoseconds, just you have to identify this critical path, okay, and this is 1 nanosecond, and you are here AND gate delay 2 nano, and this multiplexer 1 nano is equals to 2 plus 2 4, 5, 6 nano. He has given the question, right, P, Q, R, T, and apply simultaneously a maximum propagation delay of the circuit, in nanoseconds. In nanoseconds they will give you, no doubt, we have to enter 6. So, for this kind of questions, no range is available. As it is an integer, you should write 6 only. Very good here. 6, 212, Ali, CR7. PQ and gate also N consider, not consider. What? PQ and gate, what do you mean by PQ and gate, China? PQ and gate, na? Right, PQ and gate. I think you understood after explanation. I am receiving this message, maybe some delay. This AND gate is considered, okay, because the signal is coming to this then only multiplexer will receive the signal from 0 when t value is 0. That is the first case, okay. This is a 0 path, this is a 1 path, okay. This is a 1 path. If S0 is 1, this is a 1 path, simple. I am changing the slide, please observe it. A 4-bit triple counter, very straightforward question. 4-bit triple counter, synchronous counters are made using flip-flops having propagation delay of 10 nanoseconds each. Worst case delay in the ripple counter and synchronous counters R and S. So, he has given R as a notation for ripple counter. Ripple counter means, what do you mean by ripple counter, guys? Asynchronous counter, 4-bit asynchronous counter. What is the time delay? T, I am not writing T directly, R indicates the time delay, okay. That is the information he has provided. So, N into propagation delay of a flip-flop plus strobe time. Strobe means extra logic gate delay, not provided. So, that is why, what is the N value has given 4? 4. Delay of each flip-flop is 10 nanoseconds. 4 into 10 nano. That implies R is equals to 40 nanoseconds. Synchronous counters. Synchronous counters means, sir, there are so many synchronous counters, sir. Ring counter, series counter, parallel counter, Johnson counter. Of course, you please verify ring counter, Johnson counter, 1 TPD is a delay. Series counter, 1 TPD plus n minus 2 into logic gate delay. Logic gate delay not provided. Parallel counter, 1 TPD of flip-flop plus logic gate delay not provided. One time logic gate delay, it is also not provided. That is why for any synchronous counter, simply what is the delay? TPD FF, propagation delay of the flip-flop, and which is equals to 10 nanoseconds. S value 10 nano. R40, S10. Simple question. Think something went wrong in the live. Let me check it. Are you getting the live, guys? Guys, please give me the reply. Are you getting the live? Okay. Changing the slide. In the figure, LED, again it is belongs to the LED based question, and you see, guys, this is the wire connected. Very interesting question. This is a connection, okay, this is a connection, we do not have any connection here, and this is another connection. LED emits a light when S1, S2, there are two switches, okay, are closed. Closed means short circuited. If it is closed, connected to this node is going to be 0, like that. Like that, different options are provided. So, please try to, okay, thank you, yeah, thank you. Actually, I am not able to see the video here, live video, but I could see your response, okay. It is okay, please go ahead, try to solve this problem. Please try to solve this problem. This is a LED, guys, very simple. Light emitting diode. It is basically a diode. To emit the light, anode should be high voltage, cathode should be at low potential. Anode is already high, okay, anode is already high. But what is our requirement? To turn on this LED, my requirement is logic 0 at this output. This is my requirement, okay. So, for particular combination of these switches, if you could able to get 0 here, LED can emit the light, we can select the option. But it is a NAND gate, okay. NAND gate output should be 0, so compulsory input lines have to be logic 1s. There is no option for us. There is only one case for the NAND gate output can be 0 when, if and only if the inputs, all inputs are set to logic 1. And gate number 1, AND gate, to get 1 at the output of this gate, gate number 1. The switches output of AND gate should be 1 means inputs should be 1s now. So, switches S1 and S2 should be open. If any of the switch is closed, AND gate output will be 0. So, that according to the requirement, my conditions, G1 output will be 1 when S1 and S2 are open, both should be open. Immediately students are going and searching, light emits when both S1 and S2 are open, okay, do not select it, you should verify the next condition also. What is the nature of this logic gate? Anyone? Can you guess what is the nature of this logic gate? Some students are saying this is a XOR gate. No, you know, maybe XOR gate, but I have given some equivalent models, right? See, for example, if you take some XOR gate, one input is X and one input is logic 1 plus 5 volts or logic 1 permanently, then this fellow act as a inverter. What is output? X XOR 1 is equals to X bar. So, this fellow just act as a inverter. So, this is just a negation operation between second terminal and output. Okay. So, because see this 5 volts is directly connected, okay, directly connected to this. That is why you please do not ask me, sir, why did you connect a NOT gate? I am not connecting a NOT gate and this is not a NOT gate, it is a behavior. What should be the output, guys? 1. In order to get 1 at the output of this output of a NOT gate, input should be 0 now. It has to be 0. Hello, this is actually connected to switch number S2. Switch number S2. If S2 is closed, then only this can be 0. To get 1 at the output of a gate number 2, this is G2, gate number 2. What is the condition? S2 should be closed. S2 should be closed. Is it possible to satisfy the conditions? Highly impossible. This is a contradictory condition. Why, man? S1, S2 should be open to get 1 here, but if S2 is closed, then only output of this XOR gate is 1. If S2 closed, output of this gate is 1, no doubt, but 0 into anything, G1 output 0. So, for this NAND gate, third gate, okay, at any cost, we cannot get 1, 1 at the input, either 1, 0 or 0, 1 will be available. So, always 0 into anything 0, bubble is there, 0 bar 1, always output of this gate is 1, it never be 0, it never be 0, hence LED never be emits the light, does not emit the light irrespective of the switch positions. So, switch may be on, off, off, any position, LED will not emit the light, okay. Let me verify the replies. Both must be closed, someone given, that is what I told you, na. Immediately you people will be attracted towards that option. Someone given A, yeah, finally 212 given the correct answer, okay. Switch open means and close is high or 1. That is why he did not give 1 and 0, there is no confusion in open and close. Open and close, it is a common sense. Close means it should be short circuited, right? It should be closed or short circuited. So, this is open mode only, okay. Close means S1 should connected to this node, okay. Even options also given in terms of open and closed, and he did not give the options in terms of switch 1 is 1, switch 2 is 0, not like that, okay. And we have discussed this in switching theory, I mean digital what we call the switch equivalent model of logic gates, how to consider certain switch as 1 or 0. Switch may be A or complement switches, that is a different story. Directly it is just open and close, close and open, that is it, okay. Yeah. Yes, I am going for next question. The gate G1 and G2 in the figure have propagation delay of 10 nanoseconds and 20 nanoseconds respectively. If the input Vi makes an abrupt change from 0 to 1 at a t equals to t naught, he has given, of course, say this is actually 1 unit of time delay, you should take it as 10 nanoseconds. Then output waveform is very simple here, this is an inverter, okay, and this is a XOR gate. invert operation and XOR gate operation. Let me take this waveform into the next slide. This is the input here. This is the input. Let me take the notations T naught 0 to T naught, okay. So, this is T naught, somewhere T naught, T1, T2, T3, T4, T5, everywhere I do not write it. So, I am assuming this is something like K. What is the K complement of input? Initially input is 0 from long time. So, initially this is 1, initially this is 1. So, once if input is changed from 0 to 1, output will change from 1 to 0. K value will change from 1 to 0, but K is having some time delay. How much? First gate is having 10 nanoseconds. Second gate is having double the first gate delay, 20 nanoseconds. That is why I am taking one unit gap as 10 nanoseconds. So, that it has to be changed from 1 to 0 here at this point, but delayed by 10 nanoseconds. So, this is a delay of 10 nanoseconds. It will be like this, okay. Invert operation with delay. Invert operation with 10 nanoseconds delay, okay. Now, I am assuming this is the output V naught without delay. First, let me draw it without delay. Without delay. You can do it with delay also, no problem, but to just overcome the confusion, without delay. What is this? XOR gate, no? XOR operation. 0 XOR 1. This is 0 and this is 1, okay. So, this is 1. 1 XOR 1, 0. And this is 0, 1 XOR 1, and this is here you see. This is actually what? 0 XOR 1. This is 1 XOR 1. 1 XOR 1 obviously 0. Opposite combinations will give you 0. I do not want to write the name notations here. You please try to understand T naught, this is T1, T2, T3. Just let me take the dots, okay. T2, T3, T4 and T5, enough. But sir, this is output? No, this is output without delay. But what is the gate 2 delay? 2 times that of gate 1 delay. He has given 20 nano. So, what is the delay? We have discussed n number of questions, right. So, take this waveform without delay, shift right with the delay units of time, okay. Shift this waveform right with the delay units. This is a waveform available here. So, 20 nanoseconds, 10 nano and then 10 nano. Then what will be the result, guys? You will get 1 only up to, look at this, 10 nanoseconds and 10 nanoseconds up to 2 nano. Shape of the waveform will not be changed, but waveform will be shifted right. So, T2 and T3. Then this is T4, T5, this is T1 and T naught. This is final output. This is a final output. T2, T3, T2, T3, option C. You please verify this problem later again. I want to cover one more question, okay, right. So, you please verify this problem later. You watch it carefully. Yeah, just going for 1 second, let me see this. It is already 8:05, it is okay. Can we get this PDF? I do not know, dear, I do not know. If PDF is available, they will place in the like in a comment, okay. You please, you give one more comment after uploading the video, then they will let you know the source, how to find the PDF. Anil Kumar, okay. Yeah, see guys, GATE 2026 revision series, actually live batches are started from, going to start from 10th January 2026. Here actually the program is, this is for CE, I mean civil engineering, ME, mechanical, EC, electrical, CS and DA. And actually the course structure is online, you see the course structure is actually live classes in the morning session, around 6 hours per day, every day 6 hours. So, the entire subject will be revised. So, one subject like 1 day, entire subject, not the exact subject, okay. from every topic and subtopic of the subject. In order to cover the concept, there will be some questions created by the faculties and they will explain. Same, this is just like a sample like this, okay. So, this is actually the information I wanted to share you, and you can contact the, you see this is a QR code and you can go through it. And pre-gate, compulsory we need to write the pre-gate, guys. At least you try to practice previous year question papers, download entire set and try to write completely by spending sufficient amount of time, exact number of hours. You should feel the real environment, then only you will get practice well for the exam, real environment, and that you can sense the real heat of the exam. That is very much needed for the students who are going to write the GATE exam. We are generally preparing one subject for 2 to 3 days, then we will go for the questions. So, not like that. We have to practice a test series, individual and mock test. That is very important, necessary, okay. Right, all the best, guys. Good luck.